My name is Fernando Tantiventos Mendoza, and I will present my evidence on the subject of econometric models. In this event, we create a regression that could explain the borders that Democratic Party has or will have. This with the intention of creating strategies for this party to run in the following elections. Let's start with the code. The first step is to upload the libraries that we are going to use. The next step is to load our database. As we previously mentioned, the database is about the USA electoral elections. The next step is to make a regression, a linear regression. In this case, we use 6 variables: graduate degree, white to Latino population, African American population, construction, extractions, maintenance and repair occupations, unemployment, and insert. Our regression was very good, have a very good R squared, and have a p-value less than 5%. It means that our variables are significant. Now we are going to test many tests to see the goodness of our model. The first test is about multicollinearity. The first test we are going to use is to make a correlation test between the variables. As we can see, well, we expect to have values not greater than 30 or negative 30, and our variables are not greater than these values, so we can rule out the presence of multicollinearity. But to be sure, we will do a BIF test. In the BIF test, we expect to have values less than 5, and again, we have values less than 5, so we completely rule out the multicollinearity in the model. In the test heterostaticity, we do a bridge Pagan and white test. In this test, we expect to have a p-value greater than 5%. In this case, we have a p-value less than 5%. So we say that we have heterostaticity in the model, and we need to correct it. Unfortunately, we can't solve this problem. Even we do 4 strikes, we square the data, we cook the data and make many things, but we failed to correct that problem. So we pass to the next test. That is the test about the autocorrelation. Okay, this is it. It is this. Okay, in autocorrelation, we do the Darwin-Watt static, and we expect to have a p-value greater than 5%. In this case, we have a p-value greater than 5%. So we say that we don't have autocorrelation on our model, but to be sure, we do the Bridge-Godfrey static. Again, we expect to have a p-value greater than 5%, and again, we have it. So we do, if we have a problem of the correlation, we can solve it with the Cockrange or methodology. So we pass to the Monte Carlo simulation. This is a method that allows us to make multiple scenarios from pessimistic to optimistic scenarios. We do this method to two distributions, normal and uniform, and we can see that it is the same data for the two distributions. We can see that the percentage is a little fewer than we expect. And finally, we saw that the distribution that is better for all variables is the normal distribution. This is the distribution that better explain of variables. And then we are going to talk about the strategies. Okay, the first strategy is about the school. And the Democratic Party must seek to promote education and increase the educational level of the people. This is because the more educated people is, they are more likely to vote for the Democratic Party. They can support the education by investing in educational, seek to encourage scholarships, or create more community college. The next strategy must address unemployment. The Democratic Party can generate more jobs to attract foreign investing by being more flexible with investors. And a second part of the proposal, the Democratic Party must maintain and increase the support that employment people receive. The final proposition is that since the majority of African American people sympathize with the Democratic Party, they will be focused in the states where this population is majority. And another part of the strategy is that the Democratic Party can show itself as a more inclusive party with all the minorities and have representatives or candidates with Asian or Latino roots in order to connect with this group. Thank you for your attention.